And the properties of logarithms are directly related to the properties of exponents. It has to be. Because if I think about, again, we go to the circles, domain and range, and we know that the exponential function takes x's to y's. Now, we know there's all real numbers in here, but what's in here? Well, if you look, x is an exponent. So if x is an exponent, that means that in here are exponents. They're exponents of that exponential. So I put in x's, get out y's. They're exponents. That means that since this is an exponential, it follows the properties of exponents. And if it follows the properties of exponents, that means that the logarithms that brings it back also follows the properties of exponents. So the things have to fit like gloves. So if this has the properties of exponents on it, this has a set of properties that act like the properties of exponents on it. So that the two can mesh together. And that's why they're going to look kind of similar. The first property is the product rule. And it says for any positive numbers, m and n, because remember we cannot take the logarithm of a negative number, that the logarithm of a product is the sum of the logs. So the property this guy is related to is this guy, that b to the x times b to the y is equal to b to the x plus y. So that says if you've got something that's multiplied together, you add the exponents. Something that's multiplied together, you add these guys are exponents. You say, well, how do I know the logarithm is an exponent? Because what's in here we called results, and it picks up results and takes them back to the domain. The domain's filled with exponents. Now, here's the thing. I learned how to work with the properties of logarithms. I never understood them. We don't understand what a logarithm is, mainly because of our calculators. And our calculators has taken it out of the realm of understanding anymore, because we press a button and we get a value, where before, when we had to work with them, before calculators, that we actually had to understand what an exponent is. Now we just learn how to work with them. So we know how they operate. I didn't understand them until I actually had to teach them. Then I knew what a logarithm was, when I had to teach somebody else how to do it. And then suddenly I began to understand what it really was. But until then, I didn't. But I could work with them. And that's what it amounts to. So it says this: if I have the log base 2 of 4 plus the log times 16, I have the logarithm of a product. It turns into the sum of the two logs. So it's the log of the first factor added to the log of the second factor. So you break the products apart. So in this case, down here, I have the log of 13 times y. So this would be log base 8 of the first factor, which is 13, plus log base 8 of the second factor, which is y. Log base 9 of 5 times x plus 1. I have two things multiplied together. It would be log base 9 of the first factor added to log base 9 of the second factor. Product turns into a sum. Now, if I go forward, I can go backwards, which says that if I have the sum, then it turns into a product of the arguments. So this says the log of 2 plus the log of 10. This would turn into the log of the first argument multiplied times the second argument, We normally just would write it as the log of 2 times x. I don't care how you write it. Sum turns into a product. This is the log of the first argument times the log of the second argument.
The only number that goes as a subscript is
the base. And that would be base 2, yeah.
So how do you say that? You say
Log base 2,
base 2.
yeah. And in this case, there's nothing there, but there is something. It's log base 10. And in 10.6, we'll focus much more on that.